Here we're going to try and review as best as we can the things we've covered this year without overwhelming you with too much to do, and hopefully get you more familiar with the things that we've done in the past and be ready for that RICE test next week. So this week's subject, or today's subject, is solving equations. And when it comes to solving equations, the main idea is to isolate the variable so that when you get down to the bottom, you just have x or a y or whatever the variable happens to be. X equals some final number that makes this a true statement. Now, some of the rules that we can use to do that are to distribute, combine like terms on the same side, get the variable on one side of the equation, solve the equation or finish solving the equation by undoing any adding or subtracting, and then any multiply or divide at the end. So then we can check our answer. So let's just try a couple. How about this one? Well, it looks like we have a set of parentheses in there with a number out front, so we're going to need to distribute the -4 by multiplying it to the two things inside the parenthesis. So we get -8b. And a -4 times 6, -24. Remember, the same rules apply as far as multiplying positive and negatives and that type of thing. Now on the right side, we have a -1b minus 10. And I put that 1 in there so we wouldn't forget that it's there. So on this particular problem, I'm going to try and put the v's on the left side. So to do that, I'm going to add 1v to both sides to take that -1v off the left side, or the right side. So add 1v, and that will leave me with -7v minus 24 equals -10. So those canceled, and that became this. Now we're going to add 24 to both sides. So we're going to add something to both sides like we mentioned in our steps earlier. And when we do that, we end up with -7v equals, and -10 plus 24 is 14. So to finish this off, all we have to do is divide both sides by -7, -7, and our final v value is -2. There you go. Now this is one of the more involved equations. It requires several steps. And I don't know if the RICE test is going to expect you to do big, giant ones like this or just medium ones like these lower ones down here in this problem. But either way, you should be able to do it. Okay, when we did this, we also found out that when we solve them, we could either get one of three possibilities. We could get x equals one number, which is one solution. We could see the x's disappear and we get two numbers that don't equal each other, which in that case means that there's no solution. Or if we solve it, the x's could disappear and we get two numbers that do equal each other, or that we recognize both numbers are the same on each side, and so that would be infinitely many solutions. So we have to be aware of those possibilities. So let's try one, and maybe this will be one of those. So first of all, I'm going to kind of work from left to right. I'm going to go ahead and combine these variables while I'm on the left side, and I'll have -6x plus 6 equals, and then I'm going to do the distribute, which technically speaking I should have done first, but in this case we're okay. It didn't hurt the left side in any way. So -6x, and then -6 times -4 is +24. Now let's move all the x's to the left side. So plus 6x plus 6x. Oh, look at that. The x's canceled out on both sides. That just leaves me with 6 equals 24. Well, that's not I have a big question about that. That's not equal. So if it's not equal, we've got one of those problems that we have no solution to. So there we go. So you can see how these can show up. Just be watching for what comes up when you solve it the normal way, and then you'll know if it's one solution, infinite solutions, or no solution. All right, then after we did equations, we went on to what we called inequalities. These were just like equations that have inequality symbols in them instead, like less than, greater than, less than or equal to, greater than or equal to. And we solve them the same way we do a regular equation, and sometimes we graph them in a certain fashion on a number line, but there are one or two little rules in here that we have to keep in mind. So we'll try to point those out as we go through a couple of examples. So again, an inequality is a math sentence that compares expressions using these symbols. And this is what the symbols mean. This is less than or fewer than, less than or equal to, or no more than, or does not exceed, or at most. So any of these phrases could mean less than or equal to. So watch for those on today's assignment or any future tests or anything you might experience. This symbol means greater than or more than or exceeds, and then this symbol means greater than or equal to, at least, or no less than. Okay, now translate this sentence into an inequality. A number y decreased by 8, a number y decreased by 8 is no greater than, which is another way of saying is less than or equal to 20. So if you need to, read them 2 or 3 times to make sure you're comfortable with what you're about to write down for your solution. The next one, the sum of 5 and b. Sum means addition, and we're going to add 5 and b. So 5 plus b is at most. At most means less than or equal to 26. So in these 2 examples, we just had to write an example of the inequality. We did not have to solve it. Okay, now we're going to talk about graphing them. So if I have an inequality that has been solved, and I'm asked to graph it, I look and I see I have y is less than or equal to -3. So I'm going to find a -3 on the number line, put a little circle there, and then I have less than or equal to, so there's a little equal sign under there, which means that this dot is going to be colored in. And then it says that y is less than this number. So I'm going to put a less than arrow on there to show that this represents all the numbers to the left of -3. On our next example, we have b is greater than 1. So here's 1. I put a nice circle, open circle. There is no equal sign under there, so we don't color this dot in. And in this case, it says b is bigger than 1. So our arrow would go off to the right because those are the numbers that are bigger than 1. All right, here's one that's a little bit bigger. So let's go ahead and solve it. It's just like a 2-step equation. So we've got to remember the Great Wall of China. So we're going to minus 10 from both sides of this Great Wall. And we're going to get 50 is greater than or equal to 5x. Then we're going to divide by 5. And 50 divided by 5 is 10. And that's greater than or equal to x. So let me move it over here where it's a little easier to see. We got a solution of 10 is greater than or equal to x. Well, this inequality is flipped around from what I'm used to. So if I flip it back over so that the x is on the left side and I can interpret it the way I'm used to interpreting it, this basically says x is less than or equal to 10. So that means I'm going to color the whole dot in at 10, and the arrow is actually going to go to the left. So all the numbers less than or equal to 10. All right, here's one more that's a little bit more of a multi-step one. So we got to do a couple more easy steps. First of all, we're going to do distributive property, 7 times u, which will give us 7u. 7 times negative 3 is negative 21, and that's less than negative 35. And then out front I got minus 9u. So negative 9u plus 7u is negative 2u minus 21 is less than negative 35. So we're going to add 21 to both sides. And I'm kind of going to have to write down here below the number line and finish this up. Minus 2u is less than negative 35 plus 21 is negative 14. Then I'm going to divide by negative 2. But this is where we have to remind each other that when you divide by a negative, when you're solving an inequality, you flip the arrow around, right? The arrow gets flipped. So you end up with u is greater than negative 14 divided by negative 2 is positive 7. So let's write that again over here a little clearer. U is greater than 7. All right, so I come to 7, put an open circle there because it just says it's greater than. And greater than from that number is to the right. And that's what it looks like when I graph u is greater than 7. So hopefully you're seeing that these are not too bad. Let's try this one. 1 plus 8 times 1 plus v is less than or equal to negative 9 plus 5v. So 8 times 1 is 8. So plus 8. And then 8 times v is 8v is less than or equal to negative 9 plus 5v. All right, so if I'm going to add 9 to both sides, I'm kind of jumping the gun here a little bit. I have 1 plus 8 plus 9. So 1 plus 8 is 9, and 9 plus 9 is 18. 18 plus 8v is less than or equal to 5v. So we minus 8v from both sides. And that gives us 18 is less than or equal to 5 minus 8, negative 3v. Divide by negative 3. 18 divided by negative 3. We got to flip the arrow again, don't we? So over here when we write our solution, the arrow goes the other way. And we'll have v. And 18 divided by negative 3 is negative 6. So this one's kind of written backwards again. I'm going to rewrite it with the v out front. So v is less than or equal to negative 6. And we're going to color in the dot at negative 6.